Welcome to kinetic theory and gas laws. Now remember that the kinetic theory that explains gases tells us that particles and gases are very far away from each other. And the forces of attraction are very weak because of the spaces they left between particles. And the particles are much smaller than the spaces that exist between them. And then it also tells us what gas pressure is all about. When you're talking about gas pressure, remember we said it's a pressure caused by the gas by colliding with themselves and the walls of a container. And so when we are looking at the behavior of a gas, we investigate a gas under different conditions. And the conditions that we're talking about where we investigate gas is volume, pressure, and the temperature. So these are the conditions through which we investigate a gas. How does it behave under these conditions? So when we are actually looking at these three variables, we tend to keep one constant. Then we investigate the others. Now, for example, when we keep temperature constant, we are talking about what is said to be Boyle's law. Now, Boyle's law states that the volume of a fixed mass of a gas is inversely proportional to the pressure acting on the gas at constant temperature. And this is what you are seeing. So volume is inversely proportional to pressure, provided that the temperature remains constant. And when we come to drawing of a graph, we expect something to come up like this. Why? When pressure increases, the volume is decreasing. When the volume is increasing, the pressure is decreasing. So it's inversely proportional. That's why you are seeing the graph. But if we were to draw a graph of pressure against 1 over volume, then the graph has to come out straight. But when we follow Boyle's law, the graph has to come out like this. And so, when we have two situations, we tend to have the formula like this one. So this formula is under Boyle's law. Pressure 1 times volume 1 equals pressure 2 times volume 2. Now, look at the question that we have there. A quantity of gas with volume 9 decimeter cubic is under the pressure of 150 kilopascals. The pressure on the gas is increased to 200 kilopascals while its temperature stays constant. What is the new volume? So this is simple. You just replace. Where there is pressure, the first pressure is 150 times 9 equal to 200 times v squared. So this is what we get now. After dividing both sides by 200, then we tend to get 6.75 decimeter cubic. So this is the volume. What you should know about it. Boyle's law. Then coming to Charles' law. Charles' law, here what we do is we keep pressure constant. So meaning that we're investigating the relationship between volume and the temperature. So what you should bear in mind is Charles' law tells us that when the fixed mass of a gas at constant is put at constant temperature, the volume is directly proportional to pressure. Meaning that when the volume increases, then it means that temperature increases, but the pressure remains the same. So now, this is a formula that we use when we are doing the calculations under Charles' law, V1 over T1, V2 over T2. Now remember, here, the temperature should be in Kelvin. So let's look at this example. a quantity of gas with volume 9 decimeter as the temperature of 27, the pressure is kept constant and the gas is heated to 52. What volume will it expand? So when we follow the formula, this is the formula that we use. Now remember that the pressure is gotten and then it's converted to Kelvin. So this 27, when you convert it to Kelvin, you get a 300. Then when you convert 52, you get 325, and that's what you are seeing on the formula there. And then when you multiply this by this by this, you divide both sides by 100, you get the volume as 9.75. Thank you for watching.